Hello class, we're about to start section 12.1 part 1, rational expressions, domain and lowest terms. Rational expressions, aka algebraic fractions, a fraction of the form p of x over q of x, where both p of x and q of x are polynomials. The domain of a rational function, all possible inputs or x values, is a set of all numbers except those that would make the denominator 0. Numbers that will make the denominator 0. I took the liberty of typing this in instead of writing it so it'll be clearer for your notes. Okay, now we scroll down here a little bit. Now we start example 1. It says find the domain of each rational function by hand. We have 2x minus 1 over 3x plus 4. So what we need to do is set 3x plus 4 equals 0. Because remember, our denominator cannot equal 0. So we will subtract 4 on both sides. And we have 3x equals negative 4. We'll divide each side by 3. And x is equal to a negative 4/3. So our answer would be all reals. Now this is the symbol for all real numbers, except a negative 4/3. And that will be our final answer. All real numbers except a negative 4/3. Now we come here to G. Now if you notice here, we have this trinomial as our denominator. So we would set this equal to 0. And I'm going to write it up here to give myself more room. We have a squared minus 3a minus 10 equals 0. Now, when we factor this, this will factor out to a minus 5 and a plus 2. And we will set that equal to 0. So we will set both of these parentheses equal 0. And we know a minus 5 equals 0 will give us a equals 5. And a plus 2 equals 0 will give us a equals negative 2. So now it would be all reals except, then we will have negative 2 and also 5. So all real numbers except for negative 2 and 5. Now we scroll down to C and D. Now with C, we have x minus 3 over 2x cubed plus 8x squared minus 42x. So we'll write that here. We have 2x cubed plus 8x squared minus 42x, and we will set that equal to 0. Now we can factor out a 2x. All of these have 2x in common. And that will leave us x squared plus 4x minus 21. And that equals 0. Now when we go through and factor this, this will factor out to be x plus 7 and x minus 3. And that's all equal to 0. So we have set all three of these values equal to 0. We have 2x equals 0, x plus 7 equals 0, and x minus 3 equals 0. So this right here, x would be 0, x would be negative 7, and x would be 3. So it would be all real numbers except 0, we can write 0, negative 7, and 3. And this is the answer for this problem. Now we come here to D. Now we will set our denominator equal to 0. So we had t squared plus 16 equals 0. Now we know we cannot factor this here, but we can subtract 16 on both sides. And we had t squared is equal to a negative 16. Now we would take the square root of both sides. And we would have t would be equal to, now remember, when we had a square root of a negative, we would take out the I, and it'd be I times the square root of 16, and it's supposed to be positive or negative. So t is equal to positive or negative. The square root of 16 is 4, so it'd be positive or negative 4i. And we know this is not real. So this is not real. And that will be our final answer. It'll be this t equal plus or minus 4i, and we know it's not real. Now, go here, actually just to add something on here, the final answer wouldn't be not real. The final answer actually would be all real numbers. And the reason why it would be all real numbers is because since a complex or imaginary number would make the denominator 0, that means we can use all real numbers for this particular problem. So your answer here would be all real numbers. Okay, now we go here to objective 2, simplifying rational expressions. It said reduce the fraction 12 over 15 to lowest terms. So we had 12 over 15. We know 3 can go into both of them. And that gives us 4/5. Now we have this, reduce the fraction 2x minus 6 to lowest terms. Now with this problem here, we can factor 2x minus 6. We can factor out a 2 and that will give us x minus 3. We know x squared minus 9 is the difference of two squares, which would give us x minus 3 and x plus 3. Now we know these x minus 3's would simplify out and we'll have 2 over x plus 3. Now one thing I want to caution you about is this here. If we had this set equal to 0, which would make this a rational equation, you got to be very careful about simplifying out early. You must first find out the zeros like we did before. You would not simplify out early like this, only with an expression. Now we go here to example 2. It says here, well, first of all, it says important. To simplify, reduce an algebraic fraction, you must have the factor form of the numerator and denominator. Reduce factors only, never reduce terms. Okay, now we go here to example 2. We have x plus 2 in our numerator. In our denominator, we can factor this out. This would be x plus 2 and x minus 4. Now we know x plus 2 and x plus 2 would simplify out, and that would leave us 1 over x minus 4, which would be our final answer. Now we go here to b. Now we look here at the numerator. We can factor out an x minus 7 and an x plus 2 for our numerator. Our denominator, we can factor out x plus 2 and x plus 6. Now the x plus 2's will simplify out, and we'll have x minus 7 over x plus 6. Now we go here to c. Now we look here in our numerator, we can factor out a 4x, and that will leave us 3x plus 2. That's our numerator. Now in our denominator, we can factor out a 4x squared, and then in parentheses, we have 2x squared plus x minus 3. Okay, so now we can still simplify out our denominator. So we will have 4x times 3x plus 2 all over. This would be 4x squared. And then we will have 2x plus 3 and x minus 1 when we factor. Now if you notice here, the only thing we can simplify out is the 4x and the 4x squared. The 4's will simplify each other out. X over x squared, we know that would leave us an x in our denominator. So in our numerator, we would be left with 3x plus 2. In our denominator, we would have x times 2x plus 3 and x minus 1. And this would be our final answer. Now we come here to D. Now with D here, let's take a look at your numerator. With your numerator, we could group these. We group the first two, we could factor out an x squared, and we would be left with x minus 3. If we group the second two, we could factor out a plus 3, and we'll be left with x minus 3. Now, still sticking with our numerator, we have x squared plus 3 in one parenthesis, and x minus 3 in the other. Now we go to our denominator. Now this 9 minus x squared. If you notice here, none of your x's are negative. So why don't we first factor out a negative 1, And if we factor out a -1, that'll make this x squared minus 9. Now we have the difference of two squares. That will factor out to x plus 3 and x minus 3. Now the only thing you can simplify out here is the x minus 3's. So then our final answer would be x squared plus 3 in our numerator, and then -1 times x plus 3. And this would be our final answer. Okay, class, now we move on to 12.1 Part 2, Rational Expressions, Graphs and Models. Objective number 1, Review of Graph Transformation. Using your graphing calculator to graph the function f of x is equal to 1 over x, state the vertical asymptote. Now what we would do is we would turn on our calculator, press our y equals, and we would clear out these values, and then we could just type in 1 divided by x and press graph. Now if you look here, now I drew it here, disregard this red line here, this was a little error, but it's these blue lines that I want you to pay close attention to. Now if you notice here, this never hits the y-axis, neither line, and it doesn't hit where x is 0, which is our denominator, because we know our denominator cannot equal 0. Now you can get some points here by going to second and graph to get a table. And as you see here at 0, it's an error. So we could write out a couple of these points here. Like we could have a table, x and y. And we could start here with -2, -1, 0, 1, and 2. So at -2 is -0.5, -1 is -1, 0 is an error, and then 1, it would be 1, and 2, it'll be 0.5. Now, our answer here would be, because we want the vertical asymptote, it's the vertical asymptote I forgot the P here, asymptote, and then it'll be the y-axis, and the vertical asymptote is just where the graph does not hit, and x is equal to 0. So this would be your final answer as your vertical asymptote. Now it says vertical asymptote is vertical lines in the form x equal a, which correspond to the zeros of the denominator of a rational function, reduced to lowest terms. Note, do not graph the asymptotes as solid lines. They are not part of the function. Graph as a dotted line that are not crossed by the graph. Now we couldn't do that because the y-axis and where x equals 0 is actually part of the graph here. You see how the graph is? The graph is always solid lines, but if the asymptote would have been at some other number like -1, then we would have drew the dotted lines. Okay, now, there may be other x values not in the domain of the original non-reduced functions which do not make an asymptote, so always reduce the function first to find the asymptotes. Now we'll get more to that later. Okay, now we go here to example 1. It says find the vertical asymptote of 5x over x cubed minus 2x squared minus 8x.